Let's look at a specific example, the standard enthalpy of formation of propane, C3H8. The standard enthalpy of formation is the enthalpy change that occurs when 1 mole of a substance is formed from its constituent elements under standard conditions. Constituent elements refer to the elements that make up a compound. The constituent elements of propane are carbon and hydrogen. Under standard conditions, carbon is a solid and hydrogen is a gas, H2 molecules. To form 1 mole of propane, 3 moles of solid carbon and 4 moles of hydrogen molecules are needed. Under standard conditions, this reaction is never going to realistically happen, meaning measuring the enthalpy change experimentally directly is impossible. However, 3 moles of carbon and 4 moles of hydrogen can be combusted easily under standard conditions to form 3 moles of carbon dioxide and 4 moles of water. Propane can also be combusted under standard conditions to form, surprise surprise, 3 moles of carbon dioxide and 4 moles of water. This means we can draw a simple cycle, a Hess cycle, using these enthalpies of combustion that we can find experimentally and the unknown enthalpy of formation of propane. We can go straight from the 3 moles of carbon and 4 moles of hydrogen gas to 3 moles of carbon dioxide and 4 moles of water, or we can, hypothetically, react the same amount of carbon and hydrogen together to form 1 mole of propane that we can then convert to the same 3 moles of carbon dioxide and 4 moles of water. We are essentially using 2 different routes to go from the carbon and hydrogen to the carbon dioxide and water. Remember Hess's law. The enthalpy change that occurs overall will be the same for route 1, directly combusting the carbon and hydrogen, as for route 2, forming propane and then combusting the propane.